take a look. Here we go. So this is where I want to go. I want to look at context. When we are looking at airplane problems, this is only true for airplane problems, okay? So I'm going to write this in so that you have it. So for airplane or airplane problems, your reference point is always north. So in other words, I'm always going to start here. That's my starting direction. So if I move this direction, it's important that you understand notation. Notice that it says east 45 degrees north. What that means is, another way of kind of reading this is 45 degrees east of north. So if I start north, I have to go east 45 degrees of north. So that would indicate this vector right there. Okay, so this would be 45 degrees, which means this is also 45 degrees because this is a right angle. Now, if I say 45 degrees west of north, again, I start north, but now I'm going west, which means it's this angle right there. And again, west of north, 120 would put you down here, and 150 would put you down here, okay? So let's say, for example, in aviation or airplane problems, you are, again, looking at that north as your starting value. So anytime that you see this, what you're really saying is east of north. That tells you that you're going to move 45 degrees this way. All right. So let's take a look at an example. So suppose an airplane pilot wishes to file a flight plan from one airport to another. The destination is 200 miles due south. So due south, again, imagine that you start at north. So if you want to go 200 miles due south, you are going this way south, okay? And you want to go 200 miles. The pilot anticipates an average airspeed of 80 miles per hour. So when they give you the 80 miles per hour, they're giving you the speed or the magnitude of the vector, okay? So this right here is direction. So let me write that in. This is the direction. And the other component to a vector is the magnitude. So the speed is the magnitude, which is the other component. So since the location of the destination airport is due south of the starting point, the airplane should be 180 degrees north due south at 80 miles an hour. So what does that look like? So take a look. So we can see here that if it's going south, it's going, like I said, this direction. And this is going at 80 miles an hour. That's why we have the speed there, or the magnitude. And then again, we always start from north and we go this way. And since we're going south, we go all the way down. Now we write this velocity vector, because that's our velocity, as 0, -80. Because if you think of the tail end, right there, this point is at 0, -80. But we don't write it as a coordinate point because, again, it has direction and it has magnitude. We have to write it using 0. We have to use the little symbol here to indicate that it's a vector. Now, it says at the average speed of 80, so now I'm looking at this part right here, at the average speed of 80 miles per hour, it will take 2.5 hours to travel the 200 miles to the destination airport. So I'm looking here, and what we have is, if it's going 200 miles per hour, I'm sorry, we have to travel 200 miles, and it's traveling at 80 miles per hour. If you guys recall, distance equals rate times time. So it's going to take 2.5 hours to get where it needs to go, which is 180 degrees due south of north. Okay, so that's that. I hope that helps. And I'm going to make another video for the other pieces of the lesson.